2, 1, go. Hello and welcome back to Calculus 2. We are starting chapter 8, and the first lecture is actually a review of everything, hopefully, we learned so far with basic integration, as is Calc 1, so basic integrals and U sub, with a little bit of, algebra peppered in here and there. The first order of business is to take a look at this integral, which actually has a lot of covered within. So the answer over here is x to the n plus 1 over n plus 1 plus c. And the reason why I want to review this one first is because this one is covering 3 different types of functions, right? So from here, this n, the exponent n can be less than 0. So if n is, now let's start with larger than 0. So n larger than 0 and whole number. So if n is larger than 0 and a whole number, we have polynomials. And then n can be less than 0 and a whole number. And in that case, we have rational function. And the third case is when n is a fraction, in which case we have radical function. So the 3 examples over here would be integral x to the 7 dx, which is going to give us 1 over 8 x to the 8 plus c. So when you have a polynomial, it simply increases the power, divide by the same value, and you're done. Now the second one is if you have, let's say, 3 over x to the 5 dx. Well, you can kick 3 outside of the integral, and you have x to the minus 5 dx. So it's still the same formula, even though the function was not polynomial. Function was rational function, but we were able to rewrite it in such a way that we can use the same formula as for polynomials. So now we have 3 times x to the negative 4 over negative 4 plus c, which gives us negative 3/4, and then x is in denominator now, x to the 4th plus c. Because that negative 4, right, pushes the x in denominator. And finally, let's say you have 4 cube root of x to the 8 dx. Well, in this case, again, you can kick 4 outside, and you can write x to the 8/3 dx. And now we use the same formula again to solve the problem where we add 1. So this would be 4, and then I have x to the 8/3 would be x to 11/3 divided by 11/3 plus c, and then we fix this, which is going to be 12 over 11 x to 11/3 plus c. You can use cube root if you want to, whatever. So this is like, let's put 1, 2, 3, right, for our 1, 2, 3 over here examples. So this x to the n is a very cool formula because it covers a lot of these functions. Now we had in the last class, we learned about the exponential and logarithmic integrals, so we don't have to worry about those now. I would like to go and review a little bit of a trig, because we are coming up in 8.3 and 8.4. First one is called trigonometric integrals, and the next one is called trigonometric substitution, right? So it would be cool to at least see, let's say, integral of secant squared x dx is equal to the tangent x plus c. So this is one of the formulas that we are going to review in the future. Now what I want to do is I want to replace this x with ax, right? So I'm going to, instead of having secant squared x, let's say you have a secant squared 3x or secant squared 5x. So to modify all of these formulas, right, and have them be better, you can go and say secant squared ax, right, dx. And that is going to have tangent ax divided by a plus c. So you see the change, right? If you only fix the constant shows up as divided by that value. So this is ax, now that's going to be ax on the other side. So ax, and then divided by a is the extra thing. Now obviously if you are to take the derivative from here, you know that the chain rule is going to kick this one outside, a, and then that a will cancel with that a to get this, right? So you can keep that in mind. We had this also with the e to the ax when we have e to the ax over a last class. So these type of modifications, just when you plug in a for any formula where you're replacing x by ax, in the result you replace x with ax and then divide everywhere by a. So and that a is just there because of the u sub. You can easily prove this using u sub. It goes for any of the formulas you guys did before for trig or whatever. So maybe we can write, let's go with sine x dx, which is negative cosine x plus c, and then the modified formula with a, integral of sine ax dx is going to be negative cosine ax over a plus c. So these are some of the values, integration. Now, the one that we care the most about is obviously u sub, because rarely you work with basic functions, right? So the u sub is what we care about a lot, and that's going to be integral of, let's go with the f prime there, and then g of f of x in here dx, right, to give us the answer on the other end. So now when you're taking a look at this, right, you are looking for the answer of g of f of x plus c. Now it doesn't mean much when you put it in this form, because, you know, to chase these values of what's what, but understanding that the integral of g dx is the capital G plus c, then you know that the g is the antiderivative of the lowercase g. And when you're taking the derivative of the top function, right, so if you are to check this, if you take the derivative of this, it would be g prime, right, so it will be g prime of f of x times f prime of x, but then g prime, we had it over there as a lowercase. So you see that you are actually getting the same on this side. That's just little verification. It's not a big deal. the most important part here is the process of how this thing works. And that would be, right, when you have, let's say, let's go with the integral of, say, square root of x plus 9 divided by square root of x dx. Now, there are a number of ways you can solve this problem. I am going to use u sub, but we are also going to do it the other way using algebra. So if you are using u sub here, that's u equals to square root of x plus 9, then your du is going to be 1 over 2 root x dx. And you immediately see that you don't have this 2 in front of the root x. You already have 1 over root x, but you don't have the 2 in front. So you fix that. Now, remember, you can't put 1/2 in front, right? Because you already have a half that you put. So now you put 2. That's the standard mistake. Usually you put the number on top and then put a half in front. But now you're putting it in denominator, which means that's already a half. So you have to put a 2 as a balance. So now when you use the u substitution from the other end, you have the 2 integral of u du. 2 integral of u du. And that's going to be just u squared plus c, which is square root of x plus 9 squared plus c. I'm actually scared to ask you to FOIL that because you forget the middle term, and then all of the Calc 2 and Calc 1 knowledge just goes to garbage because, right, you didn't FOIL. If you want to FOIL this, it's going to be x plus 18 root x plus 81. That 18 root x in the middle for the middle term is usually lost. Yes?
If you, when I write fours, a lot of them look like U's. Is it okay if I use like a different letter instead of U?
You can use any letter, yes.
Right.
Use G, it's fine.
How many,
You can use R.
How many point loss are you looking at if we somehow create the FOIL?
You don't have to FOIL. I just said leave it just in case. How many points? Yeah, it depends on the 94. It's a lot of layers to that answer. So, another standard question would be sine to the 9x cosine x dx, let's say. Another good question to practice u sub, where you say that oh, hold on, scratch that. We'll come back. The second way to do this problem. So let's go orange. You have integral of square root of x plus 9 divided by square root of x dx. Does anyone else see something else that we could do? Possibly. And make this a joke of a problem? Yes? Split in 2 fractions and then divide. Very good. Your addition is in the numerator, which means that this can split into 2 fractions and splits into 2 integrals, right? Or you can just say, just divide right away. So if I divide this, then square root of x divided by square root of x is 1, plus 9 over square root of x dx, which we can further write as the integral of 1 plus 9x to the negative 1/2 dx. And from here, we can integrate. Now you can integrate term by term, right? What's integral of 1? Very good. And plus 9x to the 1/2 divided by 1/2 plus c, which would give us x plus 18 root x plus c. And there you go. Same answer as above. We good? All right. Except in this answer, you can see the middle term, right? 18x root x. If you FOIL this one, let's do purple, I guess. I don't know. Looks like black. Oh, whatever. Square the first one, you get x. Plus 2 times when you multiply these, so that's 18 root x. And then you have plus 81, and then you have plus c. So these two are mushed together into this one, and you see that the first two are the same. So it's the same answer, just different form to write these answers in. So it's the same. All right, now is the time for that trig question that you patiently waited for. So integral of sine to the 9, let's say x. Did I use 9 last time? Yeah, right? dx. This is your Calculus 1 question. This is going to be our first question when we do 8.3 on trigonometric integrals, because this belongs to trig integrals. But this is a Calc 1 U sub question, right? Because you do have a function and derivative pair. So what's u? U is sine x, very good. And then du is cosine x dx. So you have your cosine x over here, so that's du. So the whole thing changes into integral of u to the 9 du, which is u to the 10 over 10 plus c, and then we have 1 over 10 sine to the 10x plus c. Standard u sub question, you are going to see this again. Now integral of x cubed cosine x to the 4th dx is a little bit different than the one on top. Still has trig in it, but it's a different question. So what's up with this one? Anyone? Yes.
You only have cosine, you don't have like a sine.
I don't have a sine. Good. So can we use u sub with the cosine? No. Do we have function derivative pair?
The function would be x to the 4th, and du would then be
Good.
4x cubed.
So u is x to the 4. And what's du?
4x cubed.
Okay, but I don't have the dx. I don't have a 4 over there. So you'll just want me to put this in, right?
And then do 1/4.
Beautiful. So 1/4 integral of cosine u du. What's the integral of cosine? Sine of u plus c. I don't care about u, I care about the x, right? So we'll go sine dx to the 4th plus c. Cool. Oh, this is
Negative sign. Integral of cosine, isn't that a negative sign?
the integral of sine is negative cosine. The integral of cosine is positive sine.
Oh.
But they go opposite for derivatives. Yeah. Yeah, we're good over here. Right? Perfect. Now let's see what else. Now, say I have x squared sine x dx. Right? Let's say this is the question. Doesn't it look pretty much the same as the previous one? It kind of does, right? But is it going to fit u sub? No. Hell no. It's not no. No is kind of mild. It's not going to fit it. Because you would have to pick u within the sign, but then the derivative of that x is 1 and you have x squared. So this doesn't fit at all. And this problem is actually 8.2, what we call by parts, and that's going to be learned later. I just wanted to point it out because it's so similar, right? Can I make this to be a u sub? Easy. Just put a cube over here, boom, u sub. Take this cube out, integration by parts. So there's going to be a lot of practice, right, to spot these subtle things that switch from one integration method to another. Yes?
Can you explain one more time why it's not u sub?
Well, what would you... Okay, so here we go. You want to do something, you try it, it doesn't work out, you have to abandon it, right? So what are my choices for u? Let's go simply. My choice for u would be sine x, right? If I choose u to be sine x, du is cosine x dx. I don't have a cosine, goes away. U equals x squared, du equals x. So this becomes integral of u sine, I mean this is 2x dx over here, right? Sine of what? Square root of u, maybe? And then I still don't have 2x dx. There's no way, I can't put it together. No matter what I pick for u, it's not going to work, right? So we learn quickly that integration, right, by u substitution, you find function derivative pair. Yes, I understand that the derivative of x squared is 2x and there's a single x there, but that x is buried within sine, and you can't get inside, right? So usually when we have a u sub, relax. Usually when we have the u sub, right, it's going to be the function that it's buried within another function, under the square root, within trig, within ln, within e, right, and stuff like that. Another version of this would be the integral of e to the ax dx, integral of x e to the x dx, and integral of x e to the x squared dx. I didn't even need to have that a over there, but whatever, right? So these are three separate problems. Would you agree they're all close, right? The way they look? I can even pop in another one that you will eventually see in Calc 2, not soon, but all the way at the end of the course. Now I wrote this way. Gotta move everything to fit the fourth one. So this one is going to move here. You can move all of these things by selecting them. See, select it like this, and then just move it. Like that, and just move it right here. And that gives you more space for the next one. Scissors and glue stick, I love it. Oh. No. There we go. E to the x squared dx. There we go. I wanted to squeeze this puppy in just in case, right there. So, you're looking at these four problems. Aren't they all pretty much look the same? They all have e to the some form of x squared, something, right? Now, let's talk about them, right? What's the first one? Well, simple, right? That was the last class. I even mentioned it earlier. That's the one you can solve without thinking, right? If you spend 15 seconds, you know what to do. Because that was the basic formula we learned, reviewed last class. Now, you look at the next one, and you go, oh, okay, I still have e to the x, but now there's x in front. Can you do u sub? And the answer is no, because if you just say, okay, e to the x equals u, well, then you need another e to the x, because derivative of e to the x is e to the x. You need two of those. If you say x equals u, well, that's just going to change a variable from x to u, right? Because you said x equals u. So it appears that this one cannot be done. Well, this one is, again, 8.2 by parts, which is what is the next lecture, right? So, okay, now we move to the next one. How about the next one? Can you do the next one? Yes, u equals x squared, du equals 2x, dx, put the 2, put the half, blah, 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 done. Awesome, it's a u sub. And now we get to the last one. Oh, that's a spice and a half. Nothing in 5, nothing in 6, nothing in 7, nothing in 8. Nothing solves this problem until you get to chapter 11. So you're going to wait to chapter 11 to solve this thing, because that's where, because you need that x in front for u sub, right? And if you don't have it, well, you're doomed. So we're waiting for chapter 11 on power series to solve that one. Now, why have I done this? Because I just want to show how similar these questions are, right? And they have basic integration, 8.2, 5.5, chapter 11, it's 11.4 for this one, right? So it's a lot of different sections and ideas, right, that solve very similar questions. It's not that one is E and the other one is trig, and then the next one is Ln. They're all very similar, right? So your ability to do the u sub, where you have the function derivative pair, which is the one that is done in blue over here, number 3, right, is very important, right? You need to be able to spot that. And apart from basic integral versus u sub, remember your exam is coming up next week, and you only have 2 types of integration to worry about. It's either a basic integral, maybe peppered in this a, right, like that, or it's going to be a u sub, right? Chapter 8 is going to introduce another 5 techniques, so you'll have 7 plus improper integrals and other things. So the exam 2 is going to be, you know, a lot more interesting than exam 1, where you only have two choices. Technically, you shouldn't be thinking too much, because if the integral is not basic, it has to be u sub. There is no, right? If it's not on that chart, if the integral you're staring at in a problem is not here, then it's a u sub. That's your exam 1. That's how simple exam 1 is, right? And then obviously you can do the derivative to check whether the answer you have is correct or not correct. Now, we already seen an example of using algebra to solve a problem, right? Now, there are other techniques, especially, you know, the low punch techniques that you don't consider, and they're there, right? Now, generally, these don't show up on exams or anything, but, you know, at least they're good conversation start. Let's go, you go out with dinner, and you can, you know, pull the napkin and say, look at this, right? So it will be a good, no, I'm serious, this will be a good problem for it. So say you have the integral 0 to 2, x divided by x squared plus 4x plus 8 dx. So can we do division here? No, because you can't split these fractions because the pluses are in denominator, right? You can only split when the plus signs are in the numerator. Then you can split. If they're in the denominator, you can't split. So we can't split. Can we do log division? No, because we have the higher exponent in denominator. So log division is out as well. Then you might say, well, hold on, we can do u sub. No, you can't. Because for the u sub, if your x squared plus 4x plus 8 is u, you have 2x plus 4. I don't see x plus 2 on top, right, in the numerator. So can't do u sub either. So all of these techniques that are right there on the surface, right, that you guys are used to, none of them fit for this problem. So what could we possibly do? Yes?
You could split 8 into 4 plus 4.
Okay, and then
And then you could,
you were talking about factoring?
and then you could make it so it's x plus 2 squared. And then you could do sub for,
Or you can't do u plus 2 squared, because if you get x plus 2 squared, when you square the 2, you get a 4, and you have 8. Or you want to peel off one of the 4s, and then do factor.
yes.
Boss, right there. I had something else in mind, and he totally hacked it, went around what I wanted to do, right behind my back, and solved the problem. All right, that was a boss move. All right, so what he did is he said, let me go with the 4 plus 4 over here, and then I'm going to take this in this peanut, right? And factor that. And then I'll still have that factored plus 4. Awesome. And that is actually one of the ways to solve the problem. Now, what I'm going to do is what I tended to do, because that's how I am. And that is completing the square. Hello, intermediate algebra, or algebra, whatever you guys took years ago, right? Complete the square. So we have our x squared plus 4x plus 8. B is equal to 4. We need half of b squared, and half of b squared is, if b is 4, then it's a 4. So that's why you can split this into x squared plus 4x plus 4, and then another 4, which is what he did anyway. And now the first 3 give you x plus 2 squared, and you still have plus 4 over there. And that transforms this integral into x divided by x plus 2 squared plus 4 dx from 0 to 2. And now, dare I say, it's obvious. U equals x plus 2. Du equals what?
Just the x, one the x.
Actually, no. X plus 2 squared. How about that? Can we do that?
X plus 8 dx.
Because that will be wait. Now we should be able to do u sub over here. If we just do u equals x plus 2, there we go. So ux plus 2, and then this is dx. There we go. So this is the tough part. This is the tough part, to see the u sub here. You see, now when you try to do the u substitution in here, the denominator is clearly u squared plus 4, right? Now we're having the issue in the numerator because I need to replace x. And from here, x is equal to u minus 2. So u minus 2 goes there, and then du. And now to transform our limits, u1 is going to be 0 plus 2, which is 2. So the bottom limit is 2. And the u2 upper limit is 2 plus 2, which is 4. So now we don't have to go back to x. In your case, you're not using u's, right? You're using g's or something. So now we are at the point where we have to split into two integrals. So we have the first integral, 2 to 4, of u over u squared plus 4 du minus another integral 2 over u squared plus 4 2 to 4 du. Oh, we should lock the doors by now because not anyone running out. What's the first integral? Is going to be another u substitution, so call it now g substitution or whatever. So we have g equals u squared plus 4. So that's going to be dg is equal to 2u du. I don't have a 2, so I'll put 2.5 in front. Great. So that's my first integral. For the second integral, I'm going to kick 2 outside. Well, I need to write the first integral. So 1/2 integral of, and now this is going to be dg over g. And I need to change my limits again into g limits, so I don't have to go back to u and then go back to x. So when I plug in 2, that becomes, so let me put g1. g1 is going to be 2 squared plus 4, which is 8. So the bottom limit is 8. And the g2 is going to be 4 squared 16. So 4 squared 16 plus 4 is 20. So the top limit is 20 on the first integral. If you wrote this too close, you can just move it. There we go. We've got to move the d as well. Minus 2 times the integral of (1 over u squared plus 4 du). First integral is clear. What's the first integral? It's basic. That's close. ln absolute value g. There we go. Now we're talking. 8 to 20. Minus 2 times. And now this is the place where you say $1 million on a table. What's this one? Boss, inverse tangent. Inverse tangent. So 1/2 tangent inverse of u over 2, and then that one is computed. We use our old limits 2 and 4 because we did not change those. 2 and 4, we did not change those. All we need to do is to compute this and we're done. Easy peasy, huh? 1/2 ln 20 minus 1/2 ln 8, or you can do ln 20. Let's do ln 20 minus ln 8 in parentheses. ln 8, there we go. These cancel. So minus, I have tangent inverse of 4 divided by 2 of 2. Minus and minus will give me plus tangent inverse of 1. There's no plus c because it's a definite integral. So now, when you subtract ln's, they actually divide. So it's 1/2 ln of 20 over 8, which we can cancel. And then you have tangent inverse of 2 is not some number that we compute, so we'll just leave that one. But tangent inverse of 1 is a known value, which is what? Very good. So now, 20 and 8 divide by 4, you get 5/2 there. So 1/2 ln 5/2 minus tangent inverse of 2 plus pi over 4. And this is why this problem is a good problem to discuss when you're out. You know. It's a lot of good highlights in this problem. So we're going to go to the beginning of this problem and just run through this one more time. I'm going to start giving shout outs to my old students now. I'm going to start with Lauren. Hi, Lauren. So let's go back. There's the problem. Look at that, beautiful, rational problem, right? Not much going on. Nice and sweet, right? Until you start working on it. We complete the square, which is the orange stuff, and come up with this new integral here. And then we use the u substitution at that point. This type of u substitution is actually called back substitution. Your u sub 5.5 lecture has a single example when you have to do this. One example in a text only. It's called back substitution because this x over here had to be substituted by u minus 2, which you get by solving your u sub and having it written backwards. So back substitution, right? So we had that this stuff is u, so you get u squared plus 4, and then we don't have anything for x in here unless I solve x is equal to u minus 2, which is that, which is why that got there. Yes?
I have a question. Isn't it x plus 2 squared plus 8? Because over there we say x squared plus 4x plus 8, but actually it's 12.
No, we stole 4 because I needed that.
4, isn't it? Because of this square.
Well, let's square this. When I square this, I get squared, which is x squared, plus 2 times 2 is 4 times this is 4x, plus 2 squared is 4, plus this 4 is 8.
But there's no more plus 4, isn't it?
There is no more plus 4s. We split. Now, if you want to use this one, you will say, don't worry about this 8. You will say plus 4 minus 4,
Oh my, okay.
right? Plus and minus 4. So that's where that 4 would get rid of it. Make sense? Good. So now, when we did this, right, you have u minus 2. As soon as you have additional subtraction in the numerator, one of the techniques might be split into 2 fractions. Once we split into 2 fractions, we created 2 separate problems now, 2 separate integrals. The first one was another u sub. Well, Now it's a G sub, or whatever letter you like. And then the second problem turned out to be the inverse tangent. And we were, at that point, done with the problem. So we had back U substitution, inverse tangent, and we also had the ln integral, and we had the completing the square, right? This is a good problem. Good problem. We can make it better, but good enough. Entire 8.1, guys, is this, and more of this, and more of this, and more of this, and more of this. Practice is split, right, into two fractions if you need to. Recognize the inverse tangent. That's one of the big deals that you guys sometimes don't recognize, and it's going to be needed for 8.5 to recognize the integral of 1 over 1 plus x squared dx as the inverse tangent of x plus c. That was on that chart of basic integrals, because this one came from 4.9 from Calc 1. But then we have the spicier version of 1 over a squared plus x squared dx, which is 1 over a tangent inverse of x over a plus c. So there's that one. Now, I saw also certain books put this 1 as a b, and then that becomes b over a in the formula on outside. Because we did have 2, which I kicked outside. But, you know, you can just learn with 1 and kick that value out, right? You see that we had it here, the 2. The way I dealt with it, I kicked it outside and not used it as in a formula. So I don't care whether you go 1 over this or b, doesn't matter. Ta-da! Awesome. So these two integrals that you see over here are going to, so this particular problem, right, and these types of answers at the end are 100% of your 8.5 coming up after exam. When we do partial fraction decomposition, we're going to use algebra to split problems that look like this into multiple fractions, and then some of them will be u sub into ln, some of them will be inverse tangent, right? And maybe you have basic, maybe you have 1 over x squared, which would be a basic, right? 1 x to the n integral. So that's coming up in 8.5, but right now it's just, you know, kind of cute to see this stuff. We'll obviously do much more on this as we go on. That's 8.1. It's more of a review, and then, you know, adding some of the algebra to kind of make it a little bit spicier. I am going to open the homework for this so you guys can practice, because 100% of this is actually Calculus 1. And anytime when I ran into a modification of a problem that was Calc 2, I just said, we'll see it later, right? 8.2, 8.5, Chapter 11, and all of that stuff. We didn't do any of those things today. Should we do one more? Yeah, why not? It's fun. How about the integral of x squared over x plus 1 dx? So think about this, you know, see what your neighbors think about it. Any ideas?
You have to use like that back substitution again.
Did you try it? Or that's an idea? Because I can answer yes, I can answer no, and we still have nothing from it. I did say something earlier. I kind of slid it in, you know. We don't do this because blah, 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 and then I just moved on. Now, I'm not sure if anyone picked up on it, which is exactly what you can use here. I mentioned that one thing from algebra, we didn't do the last problem because of something, and if it was different, we would use it. I don't know if you picked up on it or not. Maybe we can do it with u sub. Try it. I mean, what would you put to be u sub here? X plus 1? Try it. You know what to do. You run into a brick wall, and run the other way. You don't want to do that at the same time. You want to write something. Just submit your head. Stack of 25 exams in your head. Intimidating, huh? Yeah, but that's okay, you're 1% now. Right?
Yeah. Just gotta stay there. Yeah.
Alright, so I'm going to tell you what you missed, and then I think that this problem can be solved both ways. So yes, u sub x plus 1, that should do it, which is going to be back substitution, but there's going to be more work. Long division of polynomials.
Oh, no.
You have when you have exponents to be the same or the higher one in the numerator, long division of polynomials is going to make your life easy. Right? So now you're dividing x squared by x, that's going to leave linear term plus some blah 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 left over that you should be able to deal with using basic u sub into ln. So let's see how that good old algebra long division of polynomials goes. And if that doesn't work, then 90% of this whole course is prerequisites, which is what it makes it be so spicy. First exam, you memorize 10 equations, you show up, right? That's, you don't get that in math. You gotta do stuff, but on the other end, prereq. Taking the square, long division of polynomials.
All the other students that took the last year pissed.
It has to be a cut somewhere. You're going to be one or the other. Right?
Those are functions. Someone back burner about once.
All right, let's take a look at this problem. Solve this problem in 2 or 3 ways or 5 ways, whatever we can master. Let's start with long division because we said x to the p over x to the q, where p is bigger or equal than q, should trigger long division, meaning exponents are the same or higher exponent in the numerator. So if we do the long division, we're going to have x plus 1 divided into x squared. Well, x into x squared goes x times. When I multiply back, I get x times x is x squared plus x. And then we subtract. I'm going to have these guys cancel. I'm going to have negative x over here. And x into negative x goes negative 1. Multiply back, I get negative x negative 1. And when I subtract that, these guys cancel, and I get positive 1. So plus 1 over x plus 1 when we do the long division. So now this integral becomes x minus 1 plus 1 over x plus 1 dx. And woohoo! Right? This one at the end is going to be u equals x plus 1, du equals dx. So when I integrate, the first one is x squared over 2, minus integral of 1 is x, plus, and now I have integral of du over u, which will give me what? Excellent. ln of absolute value of u, and u is x plus 1, plus c, and we are done. So long division turned that initially bad problem into something that it's very easy to integrate term by term. Let's see the other way. Orange. We still have, so other way, we still have the integral of x squared divided by x minus 1 dx. So say you didn't recognize the long division there. I mean, you should. You see that the exponent is higher. So long division is the way to go. But let's say for some reason you didn't. And you are trying to muscle your way through this. So that's going to be u equal x minus 1, and the du is equal to dx. So at this point in life, you have to replace these things. You have your u in denominator. You have your du here instead of dx. You do not have x squared. So how do you come up with x squared? Well, from here, you are going to come up with x as u plus 1. And then because you need x squared, you're going to have u plus 1 squared. And that goes here, u plus 1 squared. So now you will FOIL into u squared plus 2u plus 1 over u du, and then you will simply divide everywhere, and you will get u plus 2 plus 1 over u du. So now we have u squared over 2 plus 2u plus ln of absolute u plus c. And remember that u was x minus 1. So now you get to plug that in, and it's x minus 1 squared over 2 plus 2 times x minus 1 plus ln of x minus 1 plus c. Now you got a FOIL. That's x squared minus 2x plus 1, everything over 2, plus 2x minus 2, plus ln of x minus 1, plus c.
It's x plus 1, not x minus 1.
No, it's x minus 1.
It was originally x plus 1.
Oh, and that's another version of the top. My bad.
Please, no.
It's okay. We can do this version of the top.
Okay, so guys, it's not a big deal. We just need to change everything. Because there is a plus over here in the denominator, and that will just propagate through the rest of the problem. So let's see, we need a plus over here. Kill me now. Which is going to create a minus over here and here. And that's now the minus. I'm working on the same problem, so I have to have the same stuff. Which means that this is a minus. Which means that this is a minus. Which makes this a minus. Which makes this a minus. And these are pluses now, because u is x plus 1. And now over here, when I FOIL, that's a plus. Now that's a minus. That stays a minus. That's a plus. And finally, x squared over 2 plus x plus 1/2 minus 2x minus 2 plus ln of x plus 1 plus c. That is x squared over 2 minus x minus 3/2 plus ln of x plus 1 plus c. Please be the same. Yes! And before you scream, oh, but 3/2 gets mushed into the c over there, so we don't worry about this one. We say it's absorbed by the constant. So now you have seen the same problem done two ways. Now clearly the long division way was the one that we just solved it quickly, right? Because we immediately had those first two polynomial terms, and then the third one worked out to be basic u sub for ln, and we're done. Where here we had a lot of foiling and a lot of back and forth to get to the same answer. Anytime you see same exponents or exponent in the numerator is bigger, immediately go with the long division. Now, this is going to become a rule that you must know in 8.5 when we do partial fraction decomposition. It would be the first step of every problem where you have exponents in that way, right? Cool. The class ends at 9, right? So 7. Oh, today is Monday. Today is a shorter day.
Oh yeah, a whole nother.
I can't teach. There's no way I can teach 8.2 in
Rush through.
rush through it.
No, actually, no. I don't know. Pretend I didn't say that.
Good thing, because you could have gone with pretend I don't exist. All right, then one more of these puppies. Should we do trig? Should we do some ln action? Ooh. Say no more. You're gonna love this problem, guys. Limits are 1 to e squared. The limits. E squared is this number, yeah. And then we have a fraction, right? It's just x. It's nothing to worry about. The numerator is ln squared of x squared dx. I looked at this and I said, oh, come on, this is... Put this one on the bed. ln squared, yes, as ln times ln. So when the square is directly on ln, that's ln times ln. Just like sine squared. X, that means sine times sine. So the same for ln's. When you put the square there, it's ln times ln. So this one technically is going to see how well you know formulas about ln from a free call. Not at all. There's one formula you need for this. And I know I talked about that formula twice, I remember. I wrote it in orange one point. Last class, I think. I had that formula that's written in orange, I think.
Is it not just like this?
No. This is the free calculus 1 formula. Section 3 point.
This is what it feels like to be mad. So young. I wasted all these years going to school. Everything's going downhill pretty
Yeah, it's going on.
Polar bears are dying. People are like crazy.
It's all go to shit. So.
I think it's like okay, safe to say. The tickets. 1996 was a pretty ballsy year.
Spend enough time.
Just titties out every day. Space Jam on the TV.
That was the day. Back in the day.
You see, when I was a child.
Oh, yeah. Well, I just
10 times. Okay, you can do that.
Professor, how would you like this problem?
Like the boss.
How would a boss tackle this problem?
Like it.
Yes. Very good.
It's the same story like where the tool is sensitive. Where's the tool? It's the tool. You can't.
Does it involve ability to turn it into
Eventually, yes.
So what about that else?
ln squared? Well, that's what you need to deal with. That action that tells you something. I will.
Struggle. I took calculus for 5 years.
Well, it's not calculus 1 that solves this problem. It's actually pre-calc
Yeah, I know.
ability to deal with these formulas. It's even further away. It's like, oh, you just made it worse. I know. It's okay.
Why do you do
Hey, it's in the book. I didn't write it. You can always send in the strongly worded letter.
This is a calculus book, not a pre-calc.
Exactly. That's why there is a pre-calculus. This is why I never understood people taking pre-calculus and then just, that's it. It's like you preheat the oven and you just turn it off. Why bother? Why go to the class if you're not going to use it?
Yeah, I'm really sure. Instead, I have to take
That's required. Why would you have the require the pre-calc and not have the right? Because
And I still Shakespearean poetry.
oh, yeah, question. You want to
I'm sure you're
What about they give you the option of either pre-calculus
Imagine all
or
like AKA
or either that nuclear physics or
4048 poetry.
what's the thing that you do in your accounting? Maybe they can give you like the choice between the two.
Yeah, they should, but they don't. You gotta do. All right. Well, let's take a look at this. So, this square over here tells us that ln of x squared should be u for the substitution. And then this square in here is there to freak you out and confuse you. So they serve completely different purposes, you can see. So now if you say u equals ln of x squared, then your du is, well, you put the x squared and then you put this one on top, and when you simplify it, you get 2 over x dx. You have x dx, you need a 2 and a 1/2 in front. And we have all of the ingredients for this to collapse into 1/2 integral of u squared du. I know! It's amazing! So next time someone goes, what do you know? You know this? And they don't. So this is immediately where you should go.
Substitution.
So this is simply 1 over 6 u cubed. And then we bring our x back in the game, which is 1 over 6 ln cubed of x squared from 1 to e squared, and then we compute that for a little bit. So 1 over 6. Now I'm going to actually put ln of e to the 4th cubed minus ln of 1 cubed, all of that times 1 over 6 to compute. That's 1 over 6. And now ln e to the 4, ln will kill e, and then you just have a 4, so you have 4 cubed over here. Minus, and ln of 1 is 0, so that's a big fat 0 right there. And you have 4 cubed over 6, which is 4 times 16 over 6. These cancel, so 32 over 3. Cool, huh?
Radical.
No, these are logarithmic and exponential. Now, I mentioned the formula which would help you work through this issue if you didn't see the derivative and the u sub right away. So let's go visit this problem a little bit in orange. Right, so we have int ln squared of x squared divided by x dx, 1 to e squared, who cares? What I want to see if I can use ln of x to the p is p ln x. Just to rewrite this little bit to help me out. So, oh great, there's a lag. Nice. So keep imagining of what I'm writing.
Okay. What are we imagining?
Well, now I have to just take this ln squared